Hey there, Emmanuel here from WebDevFuel and welcome back. Today we're going to go over exactly the different ways that you can go ahead and connect to a database and then go ahead and query it. Now when we are using Golang, there's a couple different ways that we again can go ahead, make the connection and then do the querying. Now if you've been doing web development for a while, you probably heard of an ORM. But from my experience, ORMs are great to get started with, but once a project gets more and more complex, ORMs actually get in the way. And if you take a look at communities like Golang or even Rust, those are communities which usually reject the ORM and prefer to either go the raw SQL way or use an SQL builder. And in this video, we're going to go over 4 different methods that you can go ahead and interact with a database without having to use an ORM, which again at the beginning might seem really cool because you are able to do queries in such an easy way. But once your project gets very complex, you need to start adapting your project to the ORM and not the other way around, which makes things very complex. Now, this is very hard for me to explain to you if you've never actually done a more complex project, but again, keep this in mind. At the beginning, it makes things very simple, but once you start doing more complex things inside your application and you have multiple tables communicating with each other and you need to go ahead and grab data from multiple tables, then at that point the ORM actually gets in the way and it's not really very helpful. So let's go over the 4 different ways that you can go ahead and do this so you can become a better web developer. So the first thing that we actually want to take a look at is Squirrel, which is a Golang package that allows us to essentially build queries without having to write raw SQL. Now, all of these methods that I'll show you have each their pros and cons, and we'll start by taking a look at the pros and cons of Squirrel. First of all, the pros is that first, we have less risk of SQL injection. Now, when taking a look at the raw SQL method, so when we go ahead and actually just type the raw SQL query, we also don't have that much risk of SQL injection if we know exactly what we're doing, because Golang with the SQL package actually helps us avoid doing this SQL injection. Now, if you go ahead and simply interpolate a string, so if you use, for example, the sprintf method, then in that case, you risk actually going ahead and doing a SQL injection, which could lead to an attack on your application. But if you stick with simply using the PostgreSQL, for example, $sign and then the number, so for example, $1, $2, or $3, and then passing all those values to the function, in that case, you are not that much of risk of an SQL injection. But in this case, with Squirrel, it helps us avoiding it even if we are not that proficient in web development. The second thing is that it is easier to understand and maintain compared to the raw SQL method. Now, if you go ahead and just write raw SQL by hand, then in that case, it is a bit much harder to go ahead and maintain that code in the long run. So if you don't have a developer in your team or yourself are not that experienced with SQL, it becomes much harder to go ahead and add new code into the code base that is going to communicate with the database and also maintain it in the long run. And finally, the last pro is that it is much easier to do queries based on complex business logic. So instead of just going ahead and joining a bunch of different strings based on our business logic inside, let's say, a controller or a handler, in this case, in the case of Go, you simply go ahead and use all the methods that Squirrel provides, and in that case, it becomes much easier to go ahead and, let's say, make a type of query based on an if statement, instead of just again going ahead and joining 2 different strings or doing a lot of more complex stuff when it comes to raw SQL. Now let's take a look at the cons of using an SQL builder like Squirrel. And first of all, we have the less performant than hand optimized queries. Now this again is the case if you already have some knowledge of SQL, but usually if you are proficient with SQL and you go ahead and write all your queries by hand, you usually get a much better result than using this type of SQL builder in your code. And finally, it also requires you to learn a new API to interact with a database, which does not translate to other languages. So let's say that you've been a Java developer for a few years and now you want to move to Go. In that case, you would simply need to transfer all your knowledge of SQL into Go, and all of it will essentially be the same. But if you were using, let's say, an SQL builder inside of Java, you would already have all of that knowledge and it wouldn't be transferable to an SQL builder inside of Go. So that's the last con. Again, it requires you to learn a whole new API just to interact with SQL, which is also one of the disadvantages of using an ORM, and it is also a disadvantage here when using an SQL builder. Now let's go ahead and take a look at exactly how the code looks using Squirrel inside of Golang. So if we move back here and we open here our code editor, as you can see, we do here a connection to the database with pgx. So this is a package that allows us to connect to PostgreSQL. We go ahead and pass in here the context and also here our connection string. And after doing this, we go ahead and use here the she router to ensure that we can make a request here to the base path. And then when we do that, we go ahead and select here from all of the tasks that we have inside of the database. Now I went ahead and previously already did this inside of the database. So I went ahead and created here a table called tasks, which has an ID, a title, a description, and also a completed value, which is Boolean. And then using this data, we can simply go ahead and request it from our database. So as you can see, in order to do this, instead of having to manually go ahead and write this SQL query, we simply go ahead and use here SQ, which is the package. So if we take a look up here, as you can see, it is github.com/masterminds/squirrel. And then we add an alias here as SQ. And then after doing this, we can simply say in here select and then dot from tasks, and we simply go ahead and say to SQL, which transforms all of these methods into an SQL query. Now after doing this, we simply go ahead and take a look here to see if we have an error when building this query. And then we simply go ahead and make this query to the database here using the dot query from our PostgreSQL pool. We pass in here also our context, and then we take a look here at the errors, and finally we go ahead and loop through all of our rows, and then for each one of those rows we go ahead and put this into our slice of tasks. And now after doing this, we simply go ahead and marshal this, and finally we return this back from our request. So each time that we make a request, all of this gets done, and then we get the response back. Now if we take a look here and we use curl to go ahead and make a request to our server, let's just confirm. So this one is on port 3000. Let's also go ahead and start this. Actually, you can simply go ahead and use go run and dot. And after doing this, let's go ahead and curl here localhost port 3000. And as you can see, we get here one task. Now to make this a little bit more understandable, as you can see, if we pipe this to GQ, it goes ahead and makes this JSON look a little bit better. And inside of the database, if we go ahead and add a new task, let's say that this task is task number 2, and then we want this one to be false, and let's also add the description. Let's keep this simple and also say this is task 2. And now if we go ahead and make the same request again to port 3000, as you can see, we now get back here, first of all, our first task. The description in this case is null, and in this case we have also the newly created task, which is task number 2, which also includes in here, as you can see, a description. Now the way we do this, so as you can see, first of all we have here this as null and then here as a string. And usually this is a problem with PostgreSQL if we don't use any kind of package, is the following way. So as you can see here on the description, we have pgtype.text, which allows us to essentially map this to our database and say that this is of type text inside of the database, and also be able to say that this is null inside of the database, which usually is a problem with Go. There's a couple different methods that people usually use. You can have, let's say, a pointer to a string, in which case it allows us to also be null, but in this case we simply use here pgtype.text, and then we get back here this response, which in which case the description can either be null or be actually a string. Now let's move back here to our SQL draw, and let's take a look at the pros and cons of using the raw SQL method. Now, in this case, first of all, we'll start by the pros, and the first pro is that we have more control over our queries, which improves the performance of our code. Now, again, if you are proficient with SQL, you are able to go ahead and make the SQL query exactly how you want it to be. And if you understand exactly what is going to be more or less performant, then you have the freedom to go ahead and make the exact query that you need for a particular, let's say for a particular handler. And I'd also say that you have more control to not be constrained by the constraint that usually exists within an ORM. So in that case, you are usually tied to, let's say, a model, if you are using something like Laravel, or the active record pattern if you are using something like Rails. But in this case, you have much more freedom in order to be able to make the exact same query that you need inside of, let's say, a handler, and get the data back exactly how you need it. So you don't ever need to get more data than you need or less data. You always get the exact data that you need, and you are able to craft those queries to be as performant as you can. Now, the second pro is that we have zero abstractions, and again, if you understand SQL, this allows you to have someone that also understands SQL come into your team and help you build a project, and in that case they are already going to understand the code base when it comes to the database interactions, because they already know SQL and they don't need to know another abstraction over SQL. And this also again helps with performance, because usually abstractions can cause a lot of performance issues, and they can also make leaky abstractions when it comes to doing those abstractions, then abstracting that database interactivity. So because of this, zero abstractions is a pro when it comes to writing raw SQL queries, which is great if you want, again, to maintain more control over your database and also make sure that it is more performant and you have less errors inside of your code base. Now let's take a look at the cons, and first of all we have in here SQL injections, which again, if you know how to use Go, you can go ahead and avoid actually having SQL injections inside of your code base, but I'll leave this in here because it increases, let's say, the odds of you having some kind of SQL injection inside of your code base if you are not, let's say, careful, and the SQL query builders help with avoiding this, and you don't have to be as vigilant when it comes to these SQL injections. Next, a con is also that the changes to the schema and the database require more work to update the code. Now, this can be avoided if you, for example, create a service to interact with the database. Let's say that you have, for example, a task service, and then you don't have to rewrite all the SQL queries manually each time that you want to do some kind of interactivity with a database, but it is a fact that using raw SQL queries will make it harder for you to go ahead and make changes if you have some kind of change to the schema or the database in the long run, especially if you don't have any kind of, let's say, type safety built into those queries. So if you do not check, let's say, with a test that those queries are actually running correctly, which you should actually go ahead and do. Usually tests help with ensuring that all of those queries actually map to something that is correct into the database. but again, raw SQL queries make it harder in the long run to maintain and to make changes to the database, and then it requires much more work in order to go ahead and update our entire code base. And finally, we have more boilerplate because we have to go ahead and manually type all of this stuff, which usually the query builders helps us with. So in this case, we also have to go ahead and type a lot more stuff, and we have in general more boilerplate when it comes to raw SQL queries. Now let's go ahead and take a look at the code when we are using raw SQL queries. And again, we are doing the exact same thing as we previously did, so I'm going to simply go ahead and skip. And as you can see, at this point, instead of going ahead and first of all building our SQL string with squirrel, we simply go ahead and type it manually. So as you can see, we have here select ID, title, description, and the completed from the tasks. And we go ahead and scan in the same way. We go ahead and loop through each one of the rows, and then we scan, and then we pass this to our response. So now let's go ahead and do here, let's go ahead and start our server. And instead of querying here the port 3000, let's go ahead and query port 3001. And as you can see, the response is the exact same thing. So the result ends up being the same. Now let's go ahead and move back to sqlx and let's take a look at the third method, and this one is a little bit different than the other ones. In this case, we are using a package called sqlc in order to go ahead and generate code from our queries and from our database schema, and then this essentially goes ahead and builds all of the Go code for us in order to go ahead and query the database without having to write any kind of SQL inside of our code. Now what this allows us to do is to essentially avoid having to write either SQL queries inside of our database or use an SQL builder, but we also don't go the ORM route, which goes ahead and maps everything to our SQL. So in this case, this is, let's say, a middle ground between both of those solutions. And what essentially happens is that inside of a file, we go ahead and specify all of our queries, and then those queries then map to a particular method inside of Go, and this simply goes ahead and makes that conversion between our SQL queries and the Go code. And we'll take a look in just a second at exactly how this looks inside our code, but for now, let's take a look at the pros and cons of this method of interacting with the database. First of all, we have less boilerplate because again, we simply go ahead and make one query inside of a file, and then this goes ahead and translates that to Go code, and we can use that Go code in multiple places inside of our database. And then if we go ahead and make a change to that particular query, we get a notice inside of our compiler that we need to, let's say, add a new field, or that a field has changed a particular name, for example. So if we have, let's say, completed inside of our tasks table, and then we want to change that to done. So we essentially want to change the name of that column from completed to done. Then if we go ahead and make that particular change inside of an SQL query, this goes ahead and make that change inside of our Go code, and then we get a notice when we try to go ahead and run our Go code, which makes this a lot much easier to interact with. And that leads me to the next point, which is the type safety. So one of the pros again of sqlc is that it allows us to have type safety when doing SQL queries to our database. Then we have another point, which is we automatically or get for free, let's say, idiomatic Go code, which makes this much easier to work with, and we get a really nice way of interacting with the database that is very structured, and we don't have to think much about it. So instead of us having to go ahead and write idiomatic Go code that is easier to not only write but also maintain in the long run, this package does it for us automatically, which is really great. And the final point here inside of the pros is that it is easier to understand, first of all, especially if you're only dealing with the part that makes the calls to the database. and then it is also easier to maintain in the long run, again because of all the reasons that I've also mentioned previously, especially the type safety. It makes it really easy for us to maintain, and also because we have less boilerplate, it is much easier to maintain these queries in the long run and to ensure that our code is running correctly. Now let's take a look here at the cons, and first of all we have here the feature gap between the SQL and sqlc. Now what I mean by this is that some features of SQL, and let's say in particular of PostgreSQL, might not be available inside of sqlc, or in this case sqlc might not know exactly how to map that from an SQL query into Go code, and in that case you'd have to go ahead and write raw SQL queries or even use Squirrel. But this is a con. Again, all of the features that we have available inside of, let's say, PostgreSQL might not be available, let's say this translation between sqlc and SQL, and because of that there might be a feature gap between both of these technologies. And finally we have an extra step that can slow down the development process, and that's because we have to go ahead and inside of a file write all of our SQL queries, and then have an extra step where we need to go ahead and build those queries into Go code, and only then we can go ahead and use those queries inside of our code, let's say inside of a handler, for example. And because of this extra step can slow you down inside of the development process, but because all of the other pros, it might go ahead and balance it itself out. So for that reason, you still need to keep this in mind, and I'd say that the best way for you to actually understand exactly the pros and cons between each one of these is to go ahead and implement them yourself, because you'll get a better feeling for what works best, not only for you as a developer, but also inside of a particular project that you're working on. Now let's take a look at the code here of sqlc, and if we move back here to our terminal, and as you can see here, instead of going ahead and either using the raw SQL builder or raw SQL, we simply go ahead and call this method, which is getTasks. Now, exactly how this works is the following. So first of all, if we take a look here at the schema, we first need to define our schema, which is, as you can see, create table tasks. So we have our tasks table, then we have the ID, the title, the description, and also the completed value. And then we have in here a query.sql file, and we simply go ahead and define in here a particular query. Now, if we take a look here at the raw code, as you can see, it is the exact same thing. So select ID, title, description, and completed from tasks. And now if we take a look at here, this is the exact same thing, but this one is formatted. And then we simply need to go ahead and pass the following. We need to pass in here 2 dashes, which is essentially an SQL comment. And then we go ahead and define the name of this method. So we want to essentially tell sqlc exactly what method we want to be called. And then when we go ahead and call this method, we go ahead and run this particular query. And then we also want to tell it if it is just one record that we are getting back from the database, if we are getting many, or if we are simply executing and we don't want to actually return anything back from the database to our Go code. So in this case, it would look either many, one, or exec, but in this case, we can leave this as many. And then if we take a look here at sqlc.yaml, as you can see, we have in here, first of all, the engine define, which is PostgreSQL. Then we tell it here the queries, which is query.sql, then the schema, and finally we pass in here the package and also the out directory, and finally our SQL package, which in this case we are using again pgx in order to go ahead and connect to PostgreSQL. And after doing all of this, if we move back here to our to this particular pane, and if we move here to sqlc, if we now go ahead and run sqlc generate, this goes ahead and generates. Now in this case we already have all of this generated for us, so this didn't actually make any kind of changes inside of our code. But after running that particular command, we then get access to this particular method, And the way that we go ahead and initialize this is by using again the db package, and that's because we've defined here the name of the package as db, and then we simply go ahead and call in here new. Then we need to pass in here our database pool, and after doing this we get in here a new queries. So as you can see, a pointer to db.queries, and after doing this we can simply go ahead and do queue and then get tasks in this case. And after doing this, it simply goes ahead and checks here for the error, and we also get our tasks in here without us having to manually go ahead and again looping through each one of the rows and then going ahead and scanning, checking through through each one of those errors. So this reduces again a lot of the boilerplate that comes with writing, for example, raw SQL queries. So as you can see here, we first of all need to go ahead and execute this, then we need to go ahead and check for the errors, and then we go ahead and loop through each one of these, then we need to scan it, and also we need to append. And in this case, in the case of sqlc, we only have one step, actually two. We first of all need to go ahead and initialize here our db, which we could actually go ahead and do outside of this particular handler, but after doing this we simply go ahead and call this method, and then we get all of the tasks back. So let's go ahead and try this inside of our terminal. So if you go ahead and run this particular program, and now instead of calling here port 3001, we call port 3002, as you can see we get the exact same result back from our curl here. And finally, let's take a look at how to interact with a database by using raw SQL queries combined with sqlx, which allows us to reduce a lot of the boilerplate, but still keep a lot of the control of writing SQL queries manually. Now, as you can see here, the first pro is again, we have more control over the queries, which allows us to have much better performance when it comes to querying our database, which is usually the first bottleneck that comes up when we are actually going ahead and putting a new application into production. So for that reason, this is a great pro because it allows us to more carefully manage our SQL queries and make sure that they are as performant as they can be. The second pro is again that we have zero abstractions, and this is the same pro that we had when we went ahead and simply wrote the raw SQL queries without sqlx, but again, because we have zero abstractions, it is much easier to understand exactly what's happening when we are interacting with a database instead of having those abstractions, and then we need to understand what those abstractions are actually doing, and it takes a lot more mental focus and mental overhead, let's say, to understand that than simply having one layer directly from our code to our SQL database. And finally, we have less boilerplate, and that is great because we don't have to do that entire dance of going ahead and looping through each one of the rows and then going ahead and checking for the errors and then scanning and then appending. So instead of doing that, sqlx allows us to simply define a slice of tasks, and we simply go ahead and return from our SQL query all of that data, and we put it into the slice of tasks directly, which allows us to have much more clear code and a lot less code, which is easier to understand. And finally, the cons are the exact same one as before with the raw SQL method. So as you can see, we have first of all, again, the SQL injections, which have a higher potential of happening. Now, this doesn't again mean that because you are writing raw SQL queries that you have an SQL injection. And again, that's because Golang provides us the tools to avoid those SQL injections. But if you are not careful, you might end up having those types of things happening inside of your code base. So this is also a con of using here raw SQL with sqlx. And the other one is that again, the changes to the schema database will require more work to update the code because we are typing all of this by hand, and then when we go ahead and make, let's say, a change to our database, we need to ensure that that change is reflected inside of our code base, and we don't have, let's say, a type safe way of telling us exactly in which spots we need to go ahead and update our code base. So because of that, it requires more work and also more attention from our part as developers. And now finally, let's go ahead and take a look at exactly how the code looks when we are using raw SQL queries combined with sqlx. So as you can see again, first of all, we need to make the connection in a specifically different way. So instead of simply going ahead and using pgx to open a pool to PostgreSQL, we actually need to go ahead and use here the sqlx package. Then we need to go ahead and call here the connect method. And we need to, first of all, call our driver that we are going to be using in order to connect to a database. And finally, we need to go ahead and pass the connection string of our connection to the database, which is the exact same one that we've used previously. And in order to ensure that the pgx driver works correctly, we need to go ahead and import here the following with here the underscore alias. So we are essentially not using this inside of our code, but this particular method needs to have it in scope. So because of that, we go ahead and import it like this. And we need to go ahead and call here /pgx/v5 and then /std_lib. So this is essentially the standard library part of it that allows us to connect here with sqlx. And after doing this, we then go ahead and name this thing instead of pool db. And after doing this, we can go ahead and call this using sqlx. Now, the way that this works is that instead of going ahead and first of all initializing our task slice and then having to go ahead and loop through each one of those rows and then go ahead and scan each one of the columns, we simply go ahead and initialize here our slice of tasks. And when going ahead and calling here this method, as you can see, this one is called select, we simply need to go ahead and pass here a pointer to this particular slice. And finally, we need to also go ahead and pass our raw SQL query, and sqlx automatically goes ahead and modifies here because we are passing a pointer value to this particular value that we have here, so a pointer to this particular value. It goes ahead and modifies the original value. So we essentially only need to then go ahead and get back here the error and then check if we have an error, and if not, we can go ahead and marshal all of our tasks and return this from our request. So again, in the other cases, we went ahead and got back here not only the error but also the tasks. But in this case, we go ahead and pass here with the ampersand a pointer to this value, and then it goes ahead and modifies it. Now, this is much simpler and a lot less boilerplate code than needing to go ahead and, if we take a look here at the raw SQL query method. So in this particular example, we only go ahead and use here pgx. And as you can see, in this case, we need to first of all grab the rows and then go ahead and look through each one of the rows, which can become very complex very easily, and we have to write a lot of boilerplate code as we start building functionality inside of our applications. And in this case, it is much easier, and we still keep all of the control of writing raw SQL queries. So let's take a look here at this pane, and if we go ahead and start here this program, and now if we go ahead and query here, so as you can see in this, if we go ahead and actually curl this here, so as you can see, in this case we have port 3003, and if we go ahead now and call here instead of 3002 3003, we get the exact same result as we got previously, with a lot less, again, boilerplate code, and in a much simpler way to interact with the database while still keeping a lot of the control that helps us when we are building complex web applications. So this is it. These are 4 different methods for you to go ahead and interact with an SQL database inside of Go, and each one again of them has their pros and cons, And I encourage you to go ahead and try each one of them inside of, for example, a toy application, so you can get a better feel at exactly how each one of them works and which of them you prefer and which one of them also applies better to a particular project. And finally, let me know in the comments below which one of these 4 methods you prefer the best and you find the easiest to work with when it comes to interacting with a database with Go.